segment bisection. Pause this video and try to approach this problem on your own. Remember to begin with text annotation. Okay, so annotating the text means identifying keywords. Key mathematical terms should be circled, numerical information just underlined, and the question squiggly line. Let's restate the given information. Since AB segment bisects TR segment, we would see then these two segments intersecting at a certain point. That point would be a midpoint. We will have to decide a midpoint of which segment the point of intersection would be. So, let's read carefully. Something bisects something else. Bisects. AB bisects. That means that AB is the doer. It is a bisector. And TR bears the consequences of that action. TR will be the segment with your hash marks because P, point of intersection, now becomes a midpoint of segment TR. But please be aware that it still is just a point between A and B for segment AB. So although I do have the case of partition here, it applies to both segments TR and AB. It is still important to notice that the situation for segment TR is much more specific. So we probably will get a lot more done if we proceed with the fact that this partition is also a bisection with the presence of a midpoint. In our mind, from the definition of a segment bisector, we must realize connection to the fact that there is a midpoint and therefore two congruent segments formed on the bisected segment, and those two segments are halves. So I'm going to start my reasoning with stating it in writing. Segment bisector implies there is a midpoint. Where there is a midpoint would be equal halves, units. How can this kind of a question be more interesting than what we've just considered? Look at this possibility. What if in this question they actually gave you the value of the length AP? What if in this question they actually gave you the length of AP? Let's take a look at this length. Please notice, before this moment, the length of AP was completely irrelevant since it wasn't even a part of TR segment. The only reason we would even look at AP is if they asked us about this length, or maybe asked us about the length of any other part on segment AB. So in that case, you will need this additional piece of information. Well, let's work with it. If AP is 3m minus 4, and we found the value of m from the relationships on segment TR, we now can use that information. So we will state the fact and complete it with the substitution and verify the work with the calculator to confirm that 56 is the number of units that stands for the length of AP. So let's experiment some more. Let's see if we can find the value of PB. PB. Well, it is a segment right here, a portion of the bisector. You want to take a pause and try to solve it on your own? Well, actually, this is kind of a trick question. You see, I wanted to check if you will jump to the conclusion that PB will be equal to AP. And it is very important to notice that you cannot do that. Since segment AB was not bisected, you cannot tell that P is its midpoint, and therefore you must not say AP is equal to PB. You also don't know anything at all about the entire length of AB, so you will not even be able to use partition postulate in this situation. The only thing that you will be able to state for sure is that in this case, we simply cannot find the length of PB. We don't have enough information. And one more fact to notice. It is important to understand that these are not the only words that could be used to describe the situation we just solved. Instead of words AB segment bisect segment TR, the following statements could have been used. It could have said segment TR is bisected by segment AB at P, but that would mean that we have exactly the same diagram and the whole process would be exactly the same because it still would mean that TR is getting the stitches and that AB is the doer, the one who does the action, is the bisector. And since it bisects a segment, it is a segment bisector. Next example. Pause the video and begin the annotation on your own. Then create a diagram. Segment AB and TR bisect each other. This means that the two segments intersect and they actually are both the doers. They both bisect each other. You have to be careful marking this diagram to make sure that your congruent segments are in the right places. Specifically, notice that the two segments TP and PR formed on one of the segments will not be congruent to the other halves. That is because nobody said that AB is actually equal in measure to TR. So you cannot assume that 4 halves would be equal. You could see that I denoted the difference by the different number of marks. So, in the back of my mind, I'm noticing that since intersection takes place, there will be partition of the segments, but I would need to be more precise because in this case, it's not just partition, but it is bisection. And I remember that when segment bisection takes place, it means that there will be a midpoint at the point of the intersection. In our case, P is a midpoint for both of the segments. I also remember that this means there will be two congruent segments formed, and although halves are equal, sometimes this form of this relationship just does not do the job, and we simply need its alternative form that says that if you take a half and double it, then the result is what the whole measure would be. So, let's label our diagram. TP and TR are both given. One of them is a half of the segment, and TR is actually the entire segment. So I already suspect that if I wanted to work with these two elements to find M, I would have to use this equation. At the same time, AP is given, so this starts to look to me just like the situation in the previous example. I wonder if you could tell how this case is different. If you are in the habit of labeling your diagrams carefully, then you will notice the differences in the fact that now P is a midpoint of AB as well. So we have two sets of halves. All right, so since I need to find the value of M, I'm noticing once again that I could be working with the segment bisector that implies the midpoint and implies that double of a half will equal to the whole. So I'm going to ask you now to help me with the substitution using geometric terms. I'll begin for you. 2 times something equals, so what goes right here? It has to be a half that is given. So it would be my TP. And the right side, very careful. TR is the whole, so that's what goes in there. Let's do the substitution of algebraic statements. Please continue. TP is 6m plus 2 and the right side. Okay. Then, of course, distributive property. Left side converts into 12m plus 4. No change to the right side. We want to get rid of the smaller term with the variable, the positive 5m. So we subtract, doing the opposite. Left side becomes 7m plus 4. We will get rid of plus 4 by subtracting 4 from both sides. So 7m now would be 21. And of course that means that the value of m is 3. So we satisfied the first question. Let's move on. What is the length of TP? Let's take a look at who TP actually is. Don't assume anything. It could be any place that you didn't think of. So TP is actually this half, and we know the expression that represents it. So we will explain that since TP equals to 6m plus 2, substitution would take place, giving us the length of TP as 20 units. Great. Let's see what else we can do here. Question C. Can we find AP? Let's see where AP is. Okay, it has its own expression, so we can also do it by substitution. Be clear in your explanation. So AP is 3m minus 4. Do not skip writing this statement or the statement of substitution. AP has a value of 5 units. And what is that other question that we can meet here? Can we now find the value of PB? Try to do it on your own. PB is this portion right here. It is also a half. There is no expression for it, but we know that halves will be congruent and therefore equal in measure. So be clear with the reasoning that since AP is congruent and therefore equal to PB, it would be the same value then, 5 units for its length. And by the way, I wonder how many of you realize that if we only wanted to, we could have found the length of entire segment in this case, unlike in the first problem. We could tell that AB then would be, given that 5 is right here, doubled, that AB would be 10 units.